Hello and welcome. Chances are you've been hearing about AI a lot. It seems like overnight these things called large language models or LLMs went from some obscure tech nerd topic to being everywhere. But how do they actually work? I mean, what's really going on under the hood? Well, today we're going to pull back the curtain and demystify the machine. I mean, you see these things, writing poetry, spitting out code, having conversations. It really feels like they understand us. But behind that magic trick is a really complex system. And that gets us to the big question for this whole explainer. What is actually happening inside that digital brain? To answer that, we've got to start with the absolute basics. We're going to build this thing up layer by layer, starting with the most fundamental idea of all. What even is a large language model? Okay, before we dive deep, let's just get our terms straight because you hear AI, generative AI, and LLM thrown around all the time, sometimes for the same thing. The easiest way to think about it is like this. AI is the huge overarching field. Inside of that, you've got generative AI, which is all about creating new stuff. And LLMs, they're the super powerful new tool inside that box. So, what's the textbook definition? An LLM is a kind of neural network, which is just a fancy term for a computer system that's kind of inspired by how our brains are wired. And it's been trained on an absolutely colossal amount of text. Its entire job, its reason for being, is to understand and, more importantly, to create language that sounds like a person wrote it. But here's the secret. If you strip away all that complexity, the core idea is shockingly simple. You know the autocomplete on your phone when you're texting and it suggests the next word? An LLM is basically just that, but on an unbelievable cosmic scale. For instance, if you give the model the words "a long time ago in," it looks at everything it's ever read and calculates the most statistically probable next word. And in this case, that's "a." Then it just does it again. A long time ago in what comes next? Galaxy. It builds out entire essays, poems, and conversations this way, just by playing a probability game, one word at a time. And this right here, this reveals a fundamental truth. A raw, out of the box LLM is not an assistant, it's a completer. If you type a question into it, its first instinct isn't to answer you, it's to predict what text is most likely to come after a question like that, which might just be another question. Now, this distinction is absolutely crucial, and we're going to come back to why in a little bit. So, if the main idea is just predicting the next word, what's the engine making it so incredibly powerful and, well, smart? That brings us to the technology that made all of this possible, the transformer. You've definitely heard of GPT, right? It stands for Generative Pre-trained Transformer. We've talked about generative, we'll get to pre-trained in a minute, but that T for transformer, that is the secret sauce. It's a special type of system, a neural network architecture that was introduced in this game-changing 2017 paper called Attention is All You Need. The absolute genius of the transformer is something called the attention mechanism. See, older models tried to read a sentence word by word, in order, and they'd often forget the beginning by the time they got to the end. Attention changed all that. It lets the model look at all the words in a sentence at the same time and decide which ones are most important to each other. It's how it understands context and nuance so well. And this architecture just completely took over the AI world for three main reasons. They're super expressive, so they can learn all the weird, complex patterns in human language. They're optimizable, which means we can actually train them on these insane amounts of data. And, this is the big one, they're efficient. You can split the training work across thousands of computer chips, which is the only reason training these giant models is even possible. Okay, so we have the core idea, next word prediction, and we have the engine, the transformer. But every engine needs fuel. And for an LLM, that fuel is just a staggering amount of data and computer power. This is where the large language model really enters the picture. A really good way to think about it is like this. The training process is like a massive act of data compression. You take a huge chunk of the public internet, books, articles, websites, and you feed it into thousands of computers for weeks or months. What you get out isn't a copy of the internet. It's like a super compressed zip file of all the patterns, ideas, and knowledge that were hidden in that data. And the scale we're talking about is, well, it's hard to wrap your head around. This number, 175 billion, that's how many parameters were in the GPT-3 model from way back in 2020. You can think of a parameter as like a little knob or a connection in the network that gets tuned during training. Having that many knobs is what lets it capture so much detail. And the growth has been just exponential. Look at this. In 2018, GPT-1 had about 110 million parameters. 5 years later, GPT-4 is estimated to have around 1.8 trillion. This explosion in size isn't just about making them bigger for the sake of it, it's what unlocked totally new abilities. And that leads us to one of the weirdest and most fascinating things in all of AI. As these models got bigger and bigger, something magical started to happen. They began to develop skills they were never ever taught, like doing math or translating languages, or even writing computer code. The researchers call these emergent properties, and it's this perfect example of the old Aristotle idea, the whole becoming much, much greater than the sum of its parts. So we have this massive, superpowered text predictor. But remember what we said earlier? By default, it just wants to complete sentences. So how in the world did we get from that to the helpful conversational sidekicks like ChatGPT we have today? This is the final and maybe the most important piece of the puzzle. Well, it was a journey. GPT-1 just proved the concept worked. GPT-2 showed some early hints it could handle multiple types of tasks. GPT-3 was a huge leap with something called few-shot learning, where you could just show it a couple examples and it would get the idea. But the real revolution, the moment this stuff broke out into the mainstream, was in 2022 with ChatGPT and a process called alignment. So what is alignment? It's the critical step that transforms that raw text completer into a useful assistant. It's all about fine-tuning the model to steer its behavior, to make it act more in line with what we humans actually want. It's how you install the guardrails to make it helpful, to keep it from saying harmful things, and to push it towards being more honest. So how do they actually do it? Well, it's a pretty clever three-step process called reinforcement learning from human feedback, or RLHF. First, you have actual people write out perfect ideal answers to questions. Then, you have those people look at a bunch of different AI-generated answers and rank them, from best to worst. This teaches a second AI model what good answers look like. Finally, you let the main AI fine-tune itself, basically trying to get the highest score possible from that second reward model. This diagram shows the whole thing. Now, it might look a little complicated, but the key takeaway is that humans are constantly in the loop. In those first two steps, we're providing feedback, defining what a good response even means. Then in the third step, the AI basically goes off and practices by itself, trying over and over to get a better score based on our preferences. This alignment loop, this was the magic that made ChatGPT possible. And the results of all this alignment work, just look at this. It's a staggering leap in what these models can do. On the uniform bar exam, a really tough test for lawyers, the model jumped from the bottom 10th percentile to the top 90th. In the biology Olympiad, it went from the 31st percentile to the 99th. Alignment doesn't just make them safer, it makes them unbelievably more capable. So, we've walked through the core idea, the engine, the fuel, and the alignment process that got us here. It's been a wild ride. So, what happens now? Where does all this go? Well, the next phase is already underway. For a while, we were all just using specific AI products, chatting with an assistant, but the focus is shifting fast. Now developers can tap into these incredibly powerful models through APIs, basically using them as a foundational engine to build a whole new generation of intelligent apps and services. And that really brings us full circle. We started with this idea that an LLM is like a compressed version of human knowledge. It takes this messy, chaotic ocean of text from the internet and distills it into something that can reason and create. The huge question for all of us now is, what do we do with it? Is this incredible new tool going to be the thing that expands human creativity, our productivity, and our potential? That right there is the question that's going to define the next chapter of our story. Thanks for watching.